A very good afternoon and a warm welcome to everyone joining us today for Future Skills Prime Career Mantra on Generative AI, built responsibly with deepfakes. I'm delighted to be your host for this exciting session. My name is Amrita, and a very good afternoon and a warm welcome to everyone joining us today for. Hi, everybody. So today we'll be delving into the fascinating world of generative AI and exploring the various ways in which we can detect deepfake as well as responsibility with these applications. This session is brought to you by Future Skills Prime, the national digital skilling platform jointly initiated by the Ministry of Information Technology and Electronics with NASSCOM. Our partner in this session is OpenWeaver, a SaaS tech company changing the way the world builds digital. OpenWeaver is an application development platform supporting over 1 million developers worldwide to build their ideas faster by reusing open source software. Throughout the session, please feel free to share your thoughts and queries using the Q&A functionality on Zoom. We are eager to hear from you, and let's make this truly interactive experience. The mentor for today's session is Ms. Pooja, who is a senior developer advocate with OpenWeaver and a technology enthusiast herself, especially when it comes to AI and ML. So thank you, Pooja, for joining us, and welcome. I hand over the session to you. Take this forward.
Thank you, Amrita, for that brief, interesting introduction. Hello, everyone. Welcome to this exclusive webinar series. So today we have our very interesting session on deepfake detection. So you will actually build a detection engine of your own. So before I actually get into the agenda for the day, I would like to quickly ask you an interesting question. Let's have our first polling question, please. So I just want to understand how many of you even understand what this term deepfake means. So to be able to get an understanding of the audience that is currently viewing this session, it would be helpful if you could pick up a choice, and based on the choice that you would pick up, I'll be also able to, take this session forward with you guys. So go ahead and punch in your answers. We will take another minute for all of you to be able to, answer this interesting polling questions on exactly what do you think is a deepfake. Okay, let's check the results, please. Okay, this is very interesting. Couple of you, those who have joined us, seems like we have an audience who is pretty, intelligent, and they understand what this deepfake technology is, which we are going to talk about today. So let's get into the agenda for the session. So today we will talk about computer vision, the technology behind helping recognize images, to be able to do image classification, identification, and whatnot. So we'll give a little basics on the computer vision concepts. We will do a kit demonstration. I'll showcase you exactly what the capability of the use case is today. We will set the solution onto our systems, and then we will discuss in details the interesting models behind this deepfake detection engine that you will build alongside with me today. And then as we discuss the concepts, you should be able to go ahead with a complete working solution of your own. So with this, we will now head over quickly to the use case that I would like to demonstrate to all of you. Okay. So we have this very interesting use case. I will just showcase you the capability of it. Okay, here is where I will actually upload an image. For now, I would like to tell you that this is the interesting image that had popped up about Mark Zuckerberg walking on the ramp. Okay, so we picked up the same image from CNN and all the authentic sources, wherein it was discussed that, he was becoming a fashionista, and this is an image that we want to now recognize as real or fake. So if you see the power of this model, if you give it a good high pixel, or I would say high resolution image, it is able to determine it as completely 100% real. So you can experiment this by actually going on the internet, picking up an image which has some decent resolution and uploading it here and checking. So the amazing part about the two models that we have used here is they are able to give us a very close accuracy of over 95% in most of your images. Okay. Only thing to remember is there should be a face that is available in the image. It should not be a pixelated image. It should be a clear high resolution image. Let's try one more image that had come, that had been talked about a lot, right? The Pope, the great Pope in a white jacket. So this is another image that I'll just pick up and showcase you. You can yourself experiment with the similar images. And the interesting part is it is able to state it as 100% fake. So there was never a case where Pope was wearing a white jacket. It was just someone who was using AI to create such interesting images, picking up a Pope image, picking up, that we had the last session where we had discussed about how you can also yourself generate images using voice. So I'll also talk about Lexica Art a bit, where we will try to generate an image and showcase you the demo. But yeah, these are the portions of the image which helped in determining this image as fake. So we'll talk about all this in detail, but this is what is our solution source for today. You have an image which you think you want to test for being fake or real. You can use this model to correctly identify it. I will also showcase you various other solutions, various other images, and how you can also check and generate images and upload here and do much more from this model in the detailed section, in the detailed session that we have with you today. So now we will head on to our community platform, from wherein you will be able to set up this kit. So I will request all of you to check in the chat where the link for the community session would be shared with you.
Yeah, Pooja, it's been shared.
Okay, great. So if you see, this is the page on exclusive webinar series on generative AI. If you will scroll down, you will see that we have a 10-minute video tutorial for you. This tutorial you can watch if you would like to revisit the essential concepts during this session. So you can check out the code explanation, you can check out how you can set up the kit, and you can also check out what were the important requirements that are used to build up this model. So key things would be discussed in this quick refresher video. Then if you go and check out the hands-on learning section, here is where we have our solution source, which is in the form of a one-click kit. So the interesting part about this one-click kit is you can set it up onto your systems directly. I will guide you on how you can set this kit onto your systems. Would also like to tell you that there is an option to get yourself certified, as well as you will get a badge by taking this assessment quiz, which is present here. Also, if you are interested, you can go down and check out the other details of the webinar that we had earlier conducted in this session on this exclusive webinar series on understanding generative AI. So we have all those recordings as well for all those who have joined us for the first time today. So now let's quickly start our setup of the kit. So I'll just do a complete screen share for that. Okay. So go ahead and click on this Candy one-click kit. This will take you to the kit page. On this kit page, apart from the basic details on how this model is being developed, there are instructions for you to follow on the deployment information. So if you are setting it up on Windows operating system, just follow the steps that I'm going through. Even if you are setting it up on other operating systems like Macintosh, Linux, Ubuntu, etc., you just have to follow this first step of downloading the repository, extracting the zip file. And then you can follow alongside with me as to what I am already doing. So I'll go ahead and click this one, click installer. This will download a zip file. So this will download it onto the default location onto your systems. Go ahead and say show in folder, extract all. Very important to extract the contents of this before you go ahead and start setting up the kit. Essentially important to extract it, just pointing it out for all those who may miss this. So yeah, my screen is completely visible. We'll double click this folder. Go ahead, you'll see a batch file. Double click this batch file. Say more info, run anyway. So this will start setting up the kit onto your systems. So you'll get the required dependencies set up onto your systems automatically. So this is the most interesting part, right? You don't have to individually set up each of these dependencies and wait for them to set onto your systems. Let these set up. Now let's quickly get into the concepts for today's session. Okay. So before we even go into the concepts for today's session, I do have another interesting polling question that I would like you to answer. Can we have the polling question, please? Okay, I hope you are able to see the polling question on your screen. So we already understood, we checked out this deepfake detection technology. What do you think is the biggest concerns that this technology is going to, create? I'm not talking about the detection. I'm just talking about the option that people are able to, put Pop's head over a white jacket, put Mark Zuckerberg's head over a fancy person walking on the ramp. So I hope you are able to answer these interesting options that we have provided. Let's go ahead and check out the results as to what all of you think. So I really like how we have been able to interact today. Most of you are aware, and awareness is what we are here for today. Even if you think that the solution is something that you may not be using, but then every one of us, I would request you to please mute yourself. I can hear something in the mic. So yeah, talking about every one of you who's here for this interesting session, you will be able to at least recognize a news article with, let's say, you are having some doubt whether it is a fake news or it is a real news. You'll be able to capture that image, put it through this model, and very closely state whether it is real or fake. So talking about the computer vision, exactly what computer vision is, we actually use this for imbibing the machine with a intelligence, with a cognition, where similar to us as humans, machine is able to see, observe, and also make decisions. So you must have heard of driverless cars, which became really popular, and how they became so popular, what exactly was feed into those cars was the artificial intelligence or the computer vision technology, where your the built model was trained as to detect obstructions, was able to capture images, and accordingly make informed decisions. So that same cognition, when we want to build it into our different products, we are using computer vision. Today we are using it for classification as one of the applications to say whether a certain image is real or fake into these two classes. You can also use it for detection. So first of all, we try to even capture a face into an image. Supposedly I'll show you examples of other images as well. And then we also have an application in tracking. Supposedly you want to track a person, then also we will use computer vision and image recognition as well as image classification technologies. So what is the motivation behind our today's session? So we want to distinguish computer generated images from real individuals. Basically, this is, deep fake detection is used for entertainment, is used for creating amazing comic videos. But apart from that, it is used primarily to diminish images, to impersonate people, to even forge certain incidents. So it is important that we are able to recognize and capture a deep fake image from a real one. So that's how we got the motivation. And especially if you think what essence it has for you, deepfake can influence elections to great extent. This could be amazing videos or images that may look completely real and have been posted by foreign nations or extremists who want to influence the way your leadership is being created or promoted. So a couple of you have already answered that it is either, it could be understood as a face that has been swapped with another person's face within a video, within an image, or let's say within a space which is not real. So there are different variations. It could be a face swap. A lip sync could be done. So it could be an actor who may have not said certain comments, but those that particular lip sync could be also synced in a way that another person's audio is matched to his face. So that is also a deep fake creation. And then we have puppet master, also a way where a certain person is being showcased to do a certain task which he or she doesn't do. And how are these created? So they are primarily created by your machine learning processes, right? You have your deep learning technology, wherein we are talking about your computer vision, your artificial neural networks, algorithms which are inspired by our human brain itself, right? So the way in which neurons create connections and synapses, and we're able to do, difficult tasks, make intelligent decisions. Similarly, things happen on the side of artificial ANN or artificial neural network. For today's detection, we are using your multitask cascaded convolutional neural network. So when we talk about this multitask cascaded neural network, MTCNN basically is used to detect a particular face within the image. Okay, it is used to detect a particular face within an image, and the probability of whether that particular face is real or fake is used, or it is being determined with the inception ResNet model. So we'll talk about the details of and the differences of these two as I will showcase you the code and explain it to you line by line. But primarily, the first model is doing what? It is trying to first locate the image, trying to first detect where the particular face is there in the image, and based on the similarity of the adjacent frames, it is doing that. Your second model, which is your inception ResNet V1, this is inspired by the inception and ResNet. Like both of these models are combined together in one, and then there were two versions of it, V1 and V2. So this second model, which does the detection of stating whether the image is real or fake, this is already pre-trained on two data sets. One is your VGG phase 2 and another is your Acacia web phase. So with this, let's have another interesting polling question quickly to gather your insights as to what you think as our viewers for today. Can we have our polling question, please? So the question is, what do you think, what are those industries which are at maximum risk from malicious use of the deepfake technology? Okay, let's see, is it you think in banking and finance, is it in healthcare, politics, or real estate? Let's go to the results quickly. Let's check how people have responded. So a couple of you think that banking and finance could also be influenced as well as politics. So yes, interesting to note your views also as we go through this session. And now, let's quickly talk about what are the data sets that I used to create this solution today. So there was face forensics. So this is a video data set for forgery detection in human faces. So it was primarily focused on forgery detection for human faces. Fake catcher is another one, which has synthesized images for deepfake detection. Already synthetic AI generated images were there. Then the third one is interestingly by Facebook, or now called as Meta, where they had this Kaggle competition, and people had actually provided a lot of interesting images and contributed to resources that are used for this detection model. So what are the steps that are followed? First, we will do face extraction. Then we will do the training of our neural network. Then we come to the tensor part, where we create a mathematical tensor of the model. A heat map is being generated to determine what are the points on the face which will help us determine whether the image is fake or real. Okay. So the challenges that were faced were, supposedly we have images of multiple people in the same image. That was one of the challenge. If there is a blurry, if we have taken a screenshot from a blurry video or even from a blurry image, let's say video/images, obstructed faces, these were the certain challenges that were faced in creating this solution. Now let's quickly get to the demonstration part, or let's say the details of our solution source today. So by now you would have been able to reach this screen. You just have to say yes, and your Jupyter notebook will open in front of you. Your Jupyter notebook will open in front of you. And we will primarily discuss the concepts here. Just say restart and run on, so that your model will take the time to load onto the system. So as I will just showcase, we have done the imports for the essential libraries. First of all, we have imported Gradio. This is used for the interface that you see at the bottom. Okay. So as of now, my model is loading. I'll just stop it and say restart and run all the cells. So first of all, it is Gradio, which is used to showcase those outline, the boxes, the text box, where we have captured the entire solution. Second is your torch. Okay. So torch is again your which is used to capture your face in the particular image. So even from torch, what we are doing, we are calculating a tensor for which we are using the neural network.functional. So for that, we have created f as an alias. Then from facenet_pytorch, specifically from this first model, from this facenet pytorch model, we are importing the MTCNN and the Inception ResNet v1. So these two are our essential two models that are used, which are imported from the facenet pytorch. Then we come to your NumPy, that is used for numerical Python. PIL is your pillow, which is used to import your image, or let's say if I showcase you the solution here, we are able to upload an image simply directly here. So that with that also we are using from pillow import image. Then we come to your computer vision, which is CV2, that is also used in the solution as one of the libraries. So this is another interesting GradCam library. So this library basically helps you in determining through a visualized heat map that we create. So basically it is used to create visualizations. What sort of visualizations we will talk about as we start mapping our face in the form of points, mathematical points. Then you have your output, classifier output for the showcase of your image regions. Here you saw earlier that we had demoed, and then you say show cam on image, and then these are just for ignoring the warnings. So step one, if you have a GPU, since these models are pretty heavy, then we set our device to CUDA, which will extract or which will help run the models through the GPU. If not, then CPU will be involved. So don't worry, if you set this for the first time, it may take some time. Let the model download onto your systems. Only for the first time, if you don't have a GPU, it will take a little longer, but not if you load it for the first time. And then what we are doing here, this is my first model, your multitask convolutional neural network. So this is my first model, and it has these various parameters called select_largest. So if I would have set this select_largest equal to true, this would have, see, we can have multiple images, like multiple person in an image. So the person or the image which it feels is the largest is selected. In case this is set to true, then there is post process, which is again set to false. Device just sets the actual device, whether it is a GPU or a CPU. After we set up some, after we do this default parameters, then we set your device to evaluation, or we set it for calculation. So we just loaded the model here and kept it ready for evaluation. Then comes in your second model, which is your Inception ResNet V1. So this we already talked is trained on 2. We can check for the other data set as well, but we'll be using the VGG phase 2 here. So if you would like, you can use Shift Tab, get here, and then also check what all you can set. So classify, we have set to true, because we want to do classification through this Inception ResNet V1. So it already have these built-in properties of already being trained on these interesting data sets. And then the number of classes is 1. Either it is, we want to determine it as a fake image or a real image. Then the device is what, again, we will have to load this on the CPU itself. There is also a checkpoint that is set so that we are able to load the model weights onto your Inception ResNet V1. So this is just a checkpoint for mapping the model weights onto the onto this model. And then once we have done that mapping, we again set it to the device, which is CPU in my case, and also load it for evaluation. So this is the different steps that are being followed, and that's how our model will be able to successfully run onto our systems. Then comes the model inference part. So this is the important part. Okay, guys, here is where you are inputting your image. So when you are inputting your image here, it will first check through the empty CNN. First, it will check whether in the image that you are checking, whether there is a face or not. If there is no face detected, it will raise an exception and it will say no face detected. So important is there has to be a face in the image. Then if it has been able to detect your image, then it will interpolate or set the size of your image to 256 by 256 and also set the mode. So there are different modes that are available. We have set it to bilinear mode. If you would like, you can set it for, let's go ahead and check. There is, so we are setting it for 4D only. We could set it for bicubic also. So linear is only for 3D ones. There is a 5D, 5D mode also available for resizing of your image. So as of now, we've used the bilinear one. You can check out the other options that are also available. And then next step, what we did, we want to map your face in the form of mathematical array numbers so that we are able to plot a graph for the face which is being captured. Okay, so we have first detected the face, then we are trying to convert, we've fixed the size of the image, put it into a mode, then we are actually putting it into a form, into a mathematical array form, so that we are able to draw a plot for it. So then what we are doing, we are saying that the previous face.s type, we are just setting the type to uint8. Then face.toDevice. Here is where we are actually setting your face to the device. And then whatever, see, what is we had, this is the face that we have determined in the image. So then we are dividing it by your 255, and then we are plotting this image, this face, we're squeezing it and then plotting it into a mathematical form. Once we have created a tensor, so it's important when we are saying this mathematical form, that is what we are calling a tensor. And once that tensor is created, from that we are then checking the model by doing masking. So how do we do the masking? We will call out our, either if we have CUDA available, fine, else we will use your CPU directly. So we use the GradCAN here, which is our actual model or our essential model for drawing the visualized heat map to determine the portion of the image. So if you see in the output as well, there were certain portions of the image which are highlighted, which are showcased. So we will do a quick deepfake detection again. And there you can see how the output actually changes. So whatever we get as a classifier output target is set to your target or the resultant output. Okay. So within the grayscale can, after your weights are added here, your previous face, the previous face, and then your visualization value, which you're getting from show cam on image, right? The one that we had plotted with the face image to plot is being set here. And then based on the resultant outcome, based on the resultant outcome of this grad cam and the visualization, if the value of the model based on the face being mapped to a plot comes out to less than 0.5, then your prediction is set to have real, or else it is determined to be fake. So you do that prediction with even confidence score being calculated for real and fake. And for that, there is this in the dictionary format where real is set to your real prediction and fake is set to your fake prediction. And as an outcome, we are getting two things. One is your masked face, right? We get your masked face here, and we get the confidence score. So these are the two things that we get here. And this is just the interface that is used to showcase you, the space where we have your input image, you have your label here, whether it is fake or real, class label. Then here is where we show what portion of this image is used to determine the image as fake or real. So all that simple interfacing is what this code is about. And then we simply launch our model here. So now let's again try to pick up an image. I'll showcase you an interesting image that I picked from so lexica art is what that can be used to generate your own AI images. So you go ahead and create a prompt as Pope Bryant in Kendrick Lamar's music video. So this was a fake image that has been circulated. I will show you with both how the response would come. So let me pick up this image and submit it. So the interesting part about this image, if you see, this is a portion which has been used to determine that it is 100% fake. So this is an image that I myself had generated using Lexica Art. You can also go ahead and generate one. I also created, okay, maybe I can demo the image creation to you guys right away. Yeah, we have the screen shared, and I will just say Lexica Art here. And here you just go and click on generate, and you can just go and say, I last used an image of Pope in a white jacket, or maybe Tom Cruise's TikTok impersonator. Okay, I will just ask it to generate it. You can use any platform. I'm just showcasing you how you can yourself. So this is the last one that I had tried to experiment on this platform. And if you see, maybe we can pick some which looks very close to the real one. Maybe these 4 images, or let's pick this one. So if I will just save this image, I will just save it in the example images folder, Lexical Art. And then I will actually use it in my model quickly. So this is the one which I just recently generated. So the last time that the AI had given me an image, this is a little shiny one, but it's able to state it as 100% fake. I'll also show you another image that I had generated, a Keanu Reeves image. So this is also an image that was generated. And still this model is interestingly close. Based on these patches, etc., it is able to state based on these areas that it is a fake image. So guys, I hope this, based on the discussion that we had as to how you can state whether you know, how well the model can help you determine an image as real or fake. I'll show you another interesting example. If you go into the folder, deep fake detection, there is an examples folder where you will see that there are different image frames that we have kept for you. If you would like, let me showcase with this fake. We have already named it as fake frame. Okay. I'll pick up an image with multiple people in it and try to submit it to the model and see whether, even within this model, it is picking up this face, which is a straight face, and then it is able to also state it as fake. Let us pick one more image. Let's say a multiple people image. If we can have, let me pick this one, but it's a fake one. Let's try a real one. Try this another image. So this is the interesting part, that it is trying to check and map through the eyes and different parts and regions of the face, where it is helping in determining whether the image is real or fake. So I hope by now you've been able to get a gist of what we discussed in today's session. So now I would be very interested in answering some of your interesting questions. Please put your queries in the Q&A. Apart from the questions that you may have already been answered for, we will try to also take questions from the Q&A section. Also, I would like to brief on exactly what we discussed in today's session. We talked about a bit basic on how you see, computer vision can be used to do face detection and image recognition. Then we also discussed how you can build up an interesting deepfake detection engine that can help you, a deepfake detection engine that can help you prevent misinformation from being fed to you. And apart from this, we also finally discussed how everything can be curated in a single one-click kit that you can set up onto your system and use this model for your own, customization, and interestingly using it for various other use cases that I may not have talked about. So now let's quickly head over to the Q&A. So
thank you so much, Pooja. I think we have some very interesting questions. So one of them is, what are some potential long-term implications of generative AI for society? So this is a conversation both of us were also having. Correct. And your thoughts, please.
So absolutely. I think it's a question that all of us, are facing these days with the invent and the quick movement that we are having in generative AI these days. Things have moved really fast. You see that there was a day where wherein I had to do all my, text document preparation. I had to do preparation for assessment, to everything. But now I can quickly tell Chat GPT that, give me a one-pager for, let's say, or an assessment, 5 assessment questions on deepfake detection. As simple as that. And quickly it will give me a response. So the implications would be that we have to keep ourselves informed. We are not sure as to what we are currently, as of now, we are in a very initial stage of generative AI. But as the progress will happen, as things will start moving, you see that currently we have these virtual backgrounds, right? Which is an AR-based technology. So then you can have your virtual avatars where me doing a session and you guys also, taking part in it. All of that will happen virtually. We don't even be able to determine whether the person who's conducting the session is real or, is an AI-based robot, a virtual avatar that has been created. And even beyond this, there would be robots doing essentially most of our tasks because they would be trained well enough on the data that is being provided. And that's why even, we see a lot of news of people trying to stop this training of the large language models that has been done by OpenAI. And there has been an open letter by Sam Altman that, we for now, there's no GPT-5 that would come. But that just came, I think, day before yesterday, that update. And as of now, we can think that they have stopped it, but we never know. So there is a trust GPT which would come from Elon Musk. There's another model which Google is working on. There's so much more that that's there in generative AI. So the potential and the implication is pretty huge. All of us have to keep ourselves geared up, even in the stream where you're not maybe interested in technology, or maybe you're not a complete person looking for a source code, but you need to be informed enough so that you're able to make quick decisions. You're able to do your task based on how the scenario for generative AI is going on.
That's absolutely perfectly summed up, Pooja. But I'm going to come in here and say that creativity is still a human thing, right?
Correct.
We'll have to.
Yeah, nothing can beat what us humans can do. So we don't have to be shattered by generative AI, but we have to make it a tool for us. We have to be upskilled enough. We have to be always be at a level that we are able to tell it, okay, at the end of the day, you are just a machine, and we are the ones who have been able to code you, create you. And
great. So Akash asks a question: when it comes to metaverse, how can we leverage Gen AI to build immersive content productively?
I think that is something I already answered, that we will have virtual avatars where these current conversation that we are having as me sitting here, I will have my own avatar talking for me and answering these questions. And we can do a tea party together in that metaverse. We will have all these conferences where our avatars would go. And let's say I will own the biggest, I could be the biggest owner of something in the metaverse. So you
Right.
know that there is a different world. Metaverse is a complete virtual world where you can be anything. And the earlier you start owning these virtual currencies, your cryptocurrencies, the better it would be in terms of metaverse.
I think Mithil also has taken from that only. He's asking, how will people monetize AI in the future? So obviously there are multiple ways, but if you could share some examples.
Sure. So if you want to say monetization, it has already started. People have started creating prompts and putting a prompt online and saying you need to pay $2. I hope you know what a prompt is, Mithil. We had this last session, even the first session, where we talked about that the way you are just giving instructions to the machine, that has become an engineering. The way you are putting your messages, your words to the machine has become a form of prompt engineering. An entire course is there. So if you go on different platforms and if you're trying to generate a specific image, you have to give really detailed, specific information. It should be very to the point. So what people have started doing, they've started using generative AI as in to create money as simple as for say $3, I'll have to buy a prompt to be able to get, say, marketing creative. You want to you don't want a graphic to be designed. You just have to put up a prompt. Your Delhi would give you the exact image that is being expected. So all that monetization can help you, get people to pay who won't understand the technology. So it's good that you are aware. It's good that you are able to at least use it for your benefit. And apart from this, you can have, so then one thing is use it for the different prompts as this technology is growing. You can create blockchain-based tools around the use of secure use of, let's say, as of now, we are sending everything to ChatGPT. There is a need that all of that comes into our own system and nothing goes to the OpenAI platform. So we are also bringing a GPT-4 kit very soon. If you would like to get hold of how we can preserve the privacy and then use it for an application where you're using ChatGPT on your local systems. So then again, that is one of the points where you can use it for monetization. We have Sai Krishna asking how we can avoid misguidance of this model. So is there any such kind of security limitations? So when you say misguidance of this model,
I think you mean misuse of the model.
misuse of the
Misuse of the tool, deep fake as a tool.
Deep fake creation as a tool. So then that's what we are here, that there is complete scenario where I showcased you only those examples which have already happened. Okay, so this Pope in a white jacket, it was a serious example of someone trying to diminish Pope's image. He is a person who's being worshipped, right, in the foreign countries, and it became a massive thing on Twitter. Everybody was talking about this. So it is actually being used for all the wrong purposes, and that's why detection and prevention of such content from being showcased to us. Now we as informed people, we quickly pick up that image, put it through this model and say, no, it is all fake. Just go, it's an AI content. I don't care. This is not the real Pope. Okay. So that's how you can prevent it. We want to say that use AI responsibly. And then if you are generating it for comic videos, so there has been complete, there was this very interesting movie for which I just don't recall the exact actor's name, for which generative AI helped create video content. So there are both ways to it, but then misinformation, misuse is something which we want to prevent. Okay, couple of you are saying, can you share the code with us? Once show all the code, please. So I'll just show you how you can set up the code onto your systems quickly. Okay, I'll just show it once again. I'll share my screen, help you get to this code.
Thank you so much, Pooja. We have another 5 minutes. So after this, we won't be able to take any more questions, but let's do a recap.
Sure. So my team member would have shared this link. This is an exclusive webinar series page that is created for you. And this page is going to live forever. Okay. So you guys can go here, check it out even later if you would like. Also, post the session, we will send you a follow-up email with the link to this page, as well as the recording of this session. So the recording will be set on this page itself. It will sit here. And there is this refresher video, which is also there. And under the hands-on learning is where you have the solution source or the code. So go ahead, please check out my screen. Click on the Candy one-click kit. It will take you to this kit page. Click on the one-click installer. It will download a zip file. Okay. It will download a zip file. Just go ahead and say show in folder. Extract the contents of this zip file. Okay. If you guys are not able to get to the source code, you may have missed the extraction step. Most of you do that. Extract it, and only after you have extracted it, double click and start setting this kit up. And also, as you say, more info, run anyway, it will ask you for so I have already one of the process running. So it won't ask, it won't get set up. But what my condition is, as you're setting up the kit, follow the instructions along. It must have asked you for setting up a Microsoft Visual C++ redistribute. So you have to say yes. Only then it will be able to set and check for other dependencies. So I have this, I hope this was clear. And if you still have issues, you can still connect with us on our community platform. You can connect with us on our community platform. We will be able to answer you even one-on-one if you would like, with all sorts of queries. Go ahead and put your queries into the chat section of this page.
Thank you so much, Pooja. This has been very, very informative, especially for me. So thank you once again. And please, everybody, request once again to please make use of the OpenWeaver offer of continuing to answer questions. Have a look at the video again. Let us know if you need any support. Thanks a lot. Thank you, everybody.
One last, words from me. So it was really interesting, even for us, to conduct a series, which was this 3-part series with all of you. And I hope you were able to get good insights from this generative AI session. You would like to get your feedback as to what more sessions you would like to have with us. So look forward to that follow-up.
Right, Pooja. Yeah. Please do let us know in the comment section of Future Skills Prime on the YouTube channel as well. And OpenWeaver, the chat section is open anyway. Thank you. Thanks a lot, everybody. Thank you for joining us. Bye.